If your DNA test shows 1% unknown, your family story may be missing a deeper record. At first, the screen looks clean, 42% from one region, 27% from another, a handful of colors on a digital map, with borders that look official enough to feel final. Then one small line will not settle. 1% unknown, trace ancestry, unassigned, broadly human, but not cleanly named. That tiny number can feel more dangerous than the large ones. The big labels match the story you heard at family dinners, in old photo albums, and on the back of immigration papers. The small label asks a different question. What did the report fail to name? The answer is not always a secret ancestor. It is not always a scandal, a lost tribe, or a hidden identity. A consumer DNA test is not comparing your genome to every person who ever lived. It is comparing pieces of your DNA to reference panels, which are collections of modern people chosen to represent populations. That part changes everything. A 1% unknown result can come from a gap in the reference panel. It can come from old mixture thinned out through many generations. It can come from a real population whose descendants were barely sampled, poorly separated, or folded into a larger label. The report looks like a verdict. It is a comparison. And before that 1% can make sense, the first thing that has to break is how most people picture the test itself. An autosomal DNA test reads markers scattered across the chromosomes you inherited from both parents. Autosomal simply means the DNA outside the sex chromosomes. It is the broad family record, the part that gets shuffled each generation like cards from two old decks. The company does not read that record and see your ancestors standing in a line. It breaks your genome into segments, compares those segments to people in its database, and asks one statistical question. Which reference group does this stretch of DNA resemble most strongly? If the match is clear, the test assigns a label. If the signal is weak, mixed, or too close to several groups at once, the company may soften the label. It may say broadly European, broadly West Asian, trace ancestry, unassigned, or unknown. That word feels mysterious because it sounds like something is missing. Most of the time, it means uncertainty. A confidence threshold sits behind the screen. The company needs enough evidence before it attaches a name to a segment. A large result, such as 30 or 40%, usually comes from many segments pointing in the same direction. A tiny result, such as 1%, may come from only a few pieces of DNA. Small pieces are fragile. They can shift when the company updates its database. They can disappear when the confidence setting changes. They can move from unknown to a named region, or from a named region back into a broader category. That does not make the result useless. It makes it conditional. The caveat matters here. A 1% unknown result is not proof of purity, superiority, identity ownership, or a secret race. It does not rank people. It does not give anyone a deeper claim to worth, land, intelligence, or destiny. It is a probability signal from a database. The same genome can be described differently by different companies because each company uses different reference panels, different algorithms, and different confidence rules. One test may call a segment North African, another may call it broadly West Asian, a third may leave part of it unassigned. The DNA did not change, the comparison tool did. That is why the tiny line on the report is so easy to overread. The map looks like Ancestry, but it is also a picture of what the database knows well, what it knows poorly, and what it cannot separate yet. Once you see the report as a comparison tool, the first contradiction appears on the map. Some regions are easier for consumer DNA companies to label because they have been sampled heavily for years. Northwestern Europe is one example. Millions of people from Britain, Ireland, Germany, Scandinavia, the Netherlands, and nearby regions have taken consumer tests, and many have deep paper trails connected to church records, census files, and local archives. That does not mean Northwestern European DNA is simple. It carries migrations, invasions, farming expansions, and older hunter-gatherer ancestry. But the modern reference coverage is often dense enough for companies to build more confident labels. Other regions are harder. Parts of Central Asia sit at the crossing point of steppe migrations, Silk Road movement, Turkic expansions, Mongol-era history, Persian influence, and local ancestry that stayed in place through all of it. A segment from that region may resemble several modern populations at once. The Caucasus creates another problem. Mountain valleys, language isolates, ancient trade routes, and local bottlenecks can preserve unusual signals. A database may know there is ancestry from that zone, but still struggle to decide which modern label fits best. Island Southeast Asia can blur in a different way. Austronesian migrations, Papuan-related ancestry, mainland Asian movement, and local island histories overlap across water. The map on a test report may show islands as separate colors, but DNA moved by boats, marriages, trade, and survival long before the report drew lines. North Africa carries its own layered record. Amazigh ancestry, Arab migrations, Mediterranean contact, sub-Saharan roots, Jewish communities, Ottoman-era movement, and older local continuity can all appear in the same region. A small segment may be real and still resist a clean modern label. Indigenous America is especially sensitive. Some communities are underrepresented because of privacy, sovereignty, historical harm, or limited participation in commercial databases. A company may have enough evidence to detect a broad Native American signal, but not enough to name a specific people responsibly. Mixed diaspora communities make the problem sharper. African American, Caribbean, Latin American, Jewish diaspora, Roma, South Asian diaspora, and other communities can carry ancestry shaped by migration, slavery, empire, conversion, caste, trade, forced movement, and intermarriage. Their DNA may not fit neatly into the older regional boxes. That is where the first model breaks. A report shows borders, but DNA does not respect the date those borders were drawn. A chromosome segment may come from a migration that happened before the nation existed, before the language changed, before the family name was adopted, or before anyone in your family kept written records. Reference populations are modern, your ancestry is older. The company compares a segment against living people selected to stand in for a region. Then the algorithm assigns the best label it can, usually with a confidence score underneath. When the segment resembles several groups, the label becomes less certain. When no group is a strong fit, the segment may become unknown. That unknown line may say less about you being strange and more about the map being unfinished. Imagine a family tree pinned to a kitchen wall. The names stop at great-grandparents because the records vanished there. Now, imagine the genetic version of that wall. A segment points somewhere real, but the reference panel has no close enough cousin to name it. The test does not deny the ancestor, it runs out of comparison. That is why 1% can carry so much emotional weight. It sits at the edge of evidence and imagination. It may be a false lead, it may be a database gap, or it may be the last visible corner of an older story. And the map does not only point sideways across geography, sometimes it points backward in time. A trace signal can come from a recent ancestor. That is the explanation many people think of first. In rough terms, 1% can resemble the average contribution of one ancestor several generations back. A parent gives you about half of your autosomal DNA, a grandparent gives about 1/4, a great-grandparent gives about 1/8. After that, the average keeps shrinking. By the time you reach a fifth great-grandparent, the expected share from one person is close to 1%. But inheritance is not a perfect measuring cup. Recombination breaks and reshuffles chromosomes every generation. One sibling may inherit a segment that another sibling does not. A person can have a real ancestor and inherit no detectable DNA from that ancestor after enough generations. Another person may retain a larger piece than the average suggests. That is why a 1% signal is a clue, not a certificate. Picture a chromosome browser on a screen. One colored strip appears on chromosome 7. Another tiny piece sits on chromosome 12. The report combines those pieces and prints a percentage. You see one line. The algorithm saw scattered fragments. Those fragments may have come through a recent ancestor whose community is poorly represented in the database. They may also come from an older mixture that was spread across a whole population long before your own family story began. That second possibility is harder to picture. Suppose a small mountain community passed through a bottleneck. A bottleneck happens when a population shrinks sharply, then grows again from fewer surviving lines. The descendants may carry some old genetic signals at higher levels than expected, simply because the surviving ancestors happen to carry them. A founder effect can do something similar. If a new community begins with a small number of people, their DNA can become unusually common among descendants. Not because it is better, not because it is purer, because chance had fewer people to work with. The evidence points in a narrower direction. Old migration routes can leave faint records inside modern families. A trading port on the Mediterranean, a caravan route through Central Asia, a plantation island in the Caribbean, a borderland village where soldiers, merchants, captives, and local families crossed for centuries. The paper record may call everyone by the same surname. The DNA may remember a wider set of crossings. This is where trace ancestry separates from family legend. A story says, "We were always from here." The genome may answer, "Here was never isolated." That does not make the family story false. It may mean the family story began too recently. Many families remember the last stable place, not every road that led there. A 1% unknown can sit inside that gap. It can be the trace of one ancestor in the last few hundred years. It can be a small inherited piece from a group that entered your family before records became reliable. It can be an old regional signal that many people in your community share, even if no one has a name for it at home. That would explain some trace results. But ancient mixture can leave signals that no modern label can name cleanly. For most of the 20th century, the human family tree was drawn too cleanly. Modern humans emerged in Africa. Some left Africa. Other human groups, such as Neanderthals, disappeared. The branches were treated like separate roads. Then ancient DNA put older bones back into the conversation. In 2010, researchers at the Max Planck Institute and their collaborators published a draft Neanderthal genome. It showed that many people outside Africa carry a small amount of Neanderthal ancestry. The old wall between modern humans and Neanderthals had not held. That same year, a finger bone from Denisova Cave in Siberia opened another door. DNA from that small bone revealed a human group now called Denisovans. The bones were limited. The genetic signal was enormous. Living people in parts of Oceania, island Southeast Asia, and Asia carried Denisovan-related ancestry. A population known mostly through fragments in a cave had left descendants with traces in their genomes. Then came the stranger layer. This does not mean your consumer report saying 1% unknown is secretly Neanderthal or Denisovan. Most consumer ancestry percentages are not designed to report archaic ancestry in that way. Neanderthal ancestry is usually measured with different methods, different reference data, and different assumptions. The point is larger. Ancient DNA proved that living genomes can preserve contact with populations that vanished, changed, merged, or left very little in the archaeological record. It showed that a human group can be real before history has a clean name for it. That is what geneticists sometimes mean by a ghost lineage. A ghost lineage is not a supernatural claim. It is a population inferred from DNA before its full physical record is found. Researchers see genetic traces in living or ancient genomes that do not match known reference groups. The signal behaves like ancestry from a missing population. No tombstone, no national flag, sometimes no complete skeleton, only the genetic shadow. For consumer testing, that idea has to be handled carefully. A company is usually not telling you that a ghost population lives in your family tree. It is saying the segment does not match its present-day reference panel strongly enough to name. Still, ancient DNA changed the background meaning of that uncertainty. Some ancestry is hard to label because the database is thin. Some is hard to label because modern populations are the result of older mixtures. Some is hard to label because the source population no longer exists in the same form. A real human population can disappear as a separate community and still leave pieces of DNA scattered among descendants. The genome kept one more record. Think of an old shoreline settlement now underwater, an inland cave where one bone survives, or a desert cemetery where the heat damaged most of the DNA. Ancient people did not leave equal evidence behind. Some regions have many preserved skeletons. Others have almost none. Modern reference panels inherit that imbalance. If living descendants of a population are well sampled, the signal becomes easier to name. If descendants were displaced, absorbed, reduced, or wary of commercial testing, the signal becomes harder. This is one reason tiny unknown segments attract so many fantasies. The empty label invites people to fill it with a story they want to be true. A royal line, a forbidden identity, a lost tribe, a famous ancient people. The danger is not curiosity. The danger is treating a weak label as a finished name. Ancient DNA made Ancestry more complex, not simpler. It did not turn every unknown line on a consumer report into a dramatic revelation. It showed that the human past was full of crossings older maps ignored. That truth is strong enough without exaggeration. The deeper explanation is powerful, but it brings the biggest danger with it: overreading a tiny number. A 1% unknown result can mean low confidence data. It can mean the algorithm saw a segment that was too short, too mixed, or too close to several populations. It can mean the database has not sampled enough people from the relevant region. It can mean older admixture spread through a community. It can mean a real recent ancestor whose descendants are poorly represented. It cannot, by itself, prove a specific tribe, nation, religion, royal family, caste, clan, or hidden identity. That distinction protects the evidence. If your report shows 1% unknown and your sibling's report does not, that does not automatically make one test wrong. Siblings inherit different chunks of DNA. One person may receive a small segment from a distant ancestor while another does not. If your parent also has the same unknown segment, the clue becomes stronger. If several cousins on one side of the family have a similar signal in the same chromosomal region, the clue becomes more interesting. Family matching can give the number context. Context matters more than the word. Company updates matter too. Consumer DNA firms revise estimates when their reference panels expand or their algorithms change. A segment that once appeared unknown may later be assigned to a broad region. A trace result may vanish because the company becomes more cautious. A label may become more specific because a newly added reference group improves the match. That can feel like betrayal. It is usually calibration. The DNA in your cells has not changed. The database has gained more comparison points, or the company has changed the confidence threshold for naming a segment. A chromosome painting tool can help, but it has to be used carefully. It shows where the company thinks ancestry segments sit along your chromosomes. Longer segments are often more useful for recent ancestry. Very tiny segments can be difficult to interpret because old recombination, statistical noise, and shared ancient ancestry can blur the signal. A single small segment is a clue. A pattern across relatives is stronger. This is where paper records return. Birth certificates, church registers, synagogue records, ship manifests, tribal enrollment history, adoption files, census categories, cemetery inscriptions, and family letters may support or weaken the genetic hint. DNA can point to a locked door. Records may show which hallway the door belongs to. No medical advice should be built from a trace ancestry label. No one should decide disease risk, diet, ability, or identity from a 1% unknown line. Health genetics and ancestry estimation are different tools, and both need proper interpretation. The caveat matters here again. A DNA report can challenge a family story, but it cannot replace every part of belonging. Community, culture, law, memory, language, adoption, and lived kinship are not dissolved by a percentage on a screen. The unknown line may deserve attention. It does not deserve worship. Once the viewer stops treating 1% as a label, the number becomes a clue that has to be tested against family evidence. Return to the screen. The same line is still there, 1% unknown. It has not become less mysterious. It has become more precise. It may be a reference panel gap, where the test can see that a segment is real but lacks the right comparison group. It may be ancient mixture, where old movements have been sliced into small fragments by generations of recombination. It may be a poorly sampled population, where living descendants exist but are missing, merged, or too lightly represented in the database. Those three explanations are not enemies. They often overlap. A population can be poorly sampled because its history included displacement, isolation, forced assimilation, or mistrust of outside researchers. That same population may carry ancient mixture from older migrations. A reference panel may then struggle to name its descendants, not because their ancestry is imaginary, but because the database is incomplete. That is the strongest reveal hidden inside the word unknown. Unknown may be the test admitting that the database ran out before the Ancestry did. The person on the report is not unfinished. The map is. Think of a small locked drawer inside the genome archive. The drawer is not empty. It contains fragments too worn, too mixed, or too poorly matched for the current catalog. One company may label the drawer broadly. Another may leave it unmarked. A future update may place a better tag on it. The drawer was always there. Family stories often have similar drawers. A grandparent who changed a surname, a birth record that never named the father, a village that switched languages after a border moved, an adoption that became a whisper, a conversion hidden for safety, a community absorbed into another name because the outside world did not record it carefully. The genome may preserve a small trace where memory was interrupted. That does not mean every unknown percentage points to drama. Sometimes it is ordinary statistical caution. Sometimes it is a segment shared across many neighboring populations. Sometimes it is a category that will disappear in the next update. But sometimes it is the first measurable sign that your family's story was larger than the version that survived. Not purer, not better, larger. The old migration map treated Ancestry like clean arrows across continents. Consumer DNA reports often treat it like colored regions on a screen. Ancient DNA forced a harder picture into view. People moved, mixed, survived bottlenecks, founded new communities, and carried old signals into new names. Your 1% unknown belongs to that world. It is not a verdict. It is not a fantasy license. It is a reminder that the genome can remember crossings that paperwork forgot, and that databases are still trying to catch up with human history. If a DNA test shows 1% unknown, DNA did reveal why. The answer is not one simple secret ancestor waiting behind the number. It is the gap between living genomes, ancient migrations, and the limits of modern reference panels. That small line may come from a missing comparison group. It may come from old mixtures shared across a region. It may come from a real ancestor whose people were never sampled well enough for the company to name them cleanly. The careful response is not to ignore it, and not to crown it with a story too quickly. Compare updates over time, check relatives, look for longer shared segments. Bring the number back to records, places, names, and family memory. Subscribe to the Genome Archive for careful genetic history, ancient DNA mysteries, and the parts of Ancestry reports most people never learn to read. No hierarchy, no purity myth, only evidence, survival, mixture, and memory.